So I want to give an example to you guys of how this would work. So neurons are just doing calculations here. I could have put, I just decided to label just a few examples, like this 0.5 represents, this neuron to this neuron, how much it's giving this neuron. And this 0.2 represents how much this 0.4 is giving to this neuron here. And this point, if I put all the numbers, then it would be pretty confusing. But just to note that here we're drawing them, the length, the edge lengths, the length of these edges does not mean anything. Or that this is farther from this doesn't mean anything either. It's just that's how people typically draw them. So this, while this value from this edge to this edge is 0.7 and this is 0.2, it doesn't matter. So the thickness of the edges doesn't mean anything, or that, that this is farther from here and this is closer. It's just the way people draw them. So you should pay attention to the values along them. But to keep things simple, I only showed it for all three of them. In reality, all of these have values. It would just be so confusing if I gave a value for each edge. Does that make sense to you guys? I'm just using these three as an example. So any questions so far? So I'm going to give you guys an example right now. So I think we might be going back to wearing masks. I'm not too sure. So this is a project, fun COVID-19 masks. So let's say we have this project, fun COVID-19 masks. And I'm going to take Alyssa. Sorry, so let me just, can I call you Alyssa here just for this space?
Yes, yeah.
Okay, Alyssa, and then we're also gonna have, I need a few more people. Maybe I'll have, I could have Elian. I can have Sarah. I can have David. I could have Baby. I can have maybe I want to have someone here, maybe. Okay, and maybe Anna here, and like who wants to be the principal here? Principal's making a decision. So we can have Lachlan with Sarah, Elian, David. We can also have Shayna. Maybe we can also have Shayna as a principal. Okay, so this is a COVID mask problem. And what happens is, I don't know, can you guys see all the names? So these are the innovators. These are the people, the idea people, the innovators. So what happens is that Alyssa, Elian, and Sarah are buddies. They've come up with this idea for let's make wearing a mask enjoyable. Okay, and let's say we have, and then we also have like Kevin here. Sorry if I didn't include you guys, so I guess we'll leave it here for the sake of it. This is Kevin in this layer. So this is an innovators, and then these are the popular kids. And these are student council. And then this is the principal, Principal Shayna. So it's kind of like polluted with like names now. I'm sorry, it's kind of like a lot of people on the principal. Okay, so the idea is that Alyssa and Elian and Sarah are the innovators. So they've come up with the idea that, hey, if you guys have to wear masks, why not decorate the masks? Like, yeah, yeah, why not like decorate the masks, make it super enjoyable. That way, if students have to wear a mask, they'll enjoy it. Like, I did this with my mask, tie-dye it, roll on the patches, make it pretty enjoyable to wear masks.
yourself, guys. The moral of the story is when life gives you lemons, make lemonade. Okay.
And then what happens is they have this idea, but they need to then see, okay, well, let's talk to the popular students, give them our idea. You know, these are just innovators. You guys could be a little bit of nerds. You know, nerds is still cool, but imagine that you may not be the most popular students. You'll talk to your popular friends here, try to get them on board with the idea. And if they're on board, they'll talk to student council, and maybe student council is like, you know, they're really close to the principal, to Principal Shayna here. So the idea is that Alyssa, Elian, and Sarah, the value inside these is how much enthusiasm they have, how much bandwidth they have for it. So Alyssa, you've got a lot of stuff going on. You guys, the three of you guys are sitting, you guys are good friends, and you're like, hey, let's like come up with this idea to decorate masks. That's a really great idea, solid. But you need to then spread the word to the popular students. But so Alyssa is like, hey, I have a lot on my plate right now. Maybe the mask, this is at my level. I'm also doing a lot of other activities. Alyssa, what other activities do you typically like to do?
I play the double bass and like orchestra.
Okay. Okay, that's cool. That's awesome.
um,
So okay, awesome. So maybe you have a lot of orchestra that you need. So you the time you can spend on this, your enthusiasm is 30%. Like you came up with the idea, but this is like you're also juggling time with school and orchestra. So you only have like 30% of your enthusiasm into this project, maybe, right? That's the time, the energy level that you can have. You have a lot on your plate. And then Elian, maybe Elian's level is at 40%. Elian, what do you typically do? Or what do you like to do for fun? Or for school or anything? Elian, can you hear me? Okay, I think maybe Alien's not there or something happened. But anyway, so Alien has a lot going on. So this is also Sarah. Sarah, maybe this is Sarah's huge idea. And maybe Sarah like can commit a lot of time to this. Sarah has a lot of free time right now, can dedicate a lot of time to this COVID mask idea. So Sarah's at like 90%, you know, enthusiasm, right? If you have a schedule filled, how much time can you dedicate? And Sarah can give pretty much her all to this. So this is the energy levels. Then what you guys will do is you guys are going to go up to talk to the popular students like David, Lachlan, and like let's say Mason, you know, Asuba, like all these people here, Evan. Sorry if I didn't put your names on this, but like you guys are then going to go up, like let's say that David is sitting having lunch, his lunch, and you guys are going to go up to David and tell him about why like your idea is really cool, so he can spread the word to the student council and then maybe to the principal so that they can try to adopt your idea. And this is just an idea I made, so I know like there could be a few loopholes, so just try to run with this idea if you can. So this is your guys' enthusiasm level for Alyssa, Elian, and Sarah. So you guys are going to go up to David and talk. So have you guys heard, like if your best friend tells you something, it's going to have something that's called weight, right? More weight. So that's sort of what this is measuring, the weight between these two neurons in a way. So Alyssa is going to talk to David. And on a scale of 0 to 1, the friendship is at like 0.5. You know, David probably thinks that they are, you know, just friends, you know, pretty okay friends. So, you know, whatever Alyssa says to David will carry some weight of 0.5. So Alyssa is going at 30% enthusiasm. This is her enthusiasm, and she's talking to David, and whatever she says carries this weight. So, and then Elian is going up next, and he's talking to David. And what do you think? Do you think that they're really good as good friends, or how would you describe them on a scale of 0 to 1? This is the weight that Elian has with David.
they're not really that great friends. Like
Yeah.
Sarah said, they're acquaintances.
Yes, yes, thanks. Yep, there and thanks, Elasan. Yep, they're just more like acquaintances. So it's like almost like a buddy you've seen in the class. Maybe you just wave or you just see them, or you just know who they are. So Elian just goes talks to David. So whatever Elian says is not going to have too much weight. Yes, exactly. As Brianna said, it's probably not as much of an impact. And then Sarah is going to go talk to David. Sarah has a lot of enthusiasm. And how would you describe their friendship with David, her friendship with David?
It's much better, but it's like not 100%.
Yeah, so they might be just like good friends, maybe not like the best friends of a close friend, reasonable enough. So basically, David is sitting, he's having lunch, and he's come up by Alyssa, Elian, and Sarah. So Alyssa's at 30%. So maybe if she might just talk to David for like just 2 minutes about it. You know, Elian might talk about for like, well, maybe she might talk for 3 minutes to David about the idea. And maybe Elian might talk for 4 minutes about the idea to David separately. And Sarah might come up and talk for 9 minutes to David about this COVID mask idea, right? She's super, super enthusiastic in a way. So what happens is David is going to take whatever he's hearing and he's going to weight it by how much these people mean to him. So he's going to pick up on their enthusiasm plus how much they mean to him. So what do you think that David is going to get from Alyssa? Like what will he get? What value will he get from her? Does anybody know? So David is talking, and don't pay attention to the point two, we'll get to that next, but just think, what does a David get from Alyssa? Okay, he gets so she has a 30% enthusiasm, but how much weight do her words have?
0.5 or 50%.
Yeah, so it's going to be 0.3 times 0.5. Because what happens is David is thinking that this is the enthusiasm that Alyssa has, 30%. But if you were to take her as a friend, his psychology is like, you know, she's a friend. So whatever she has, the weight it will have will be 50%, basically. So he's going to pick up on her enthusiasm and then at 50%. So if she's like, yeah, you know, COVID masks are great, whatever, it's like you feed off of the other person's energy, right? If your best friend's like, yeah, that's a good movie, go see it. Or if your best friend's like, oh my God, you should see this movie. It's the best movie ever. So you're going to pick up on the movie, right? Like you're going to pick up on the enthusiasm that they have. You guys see what I mean? You will pick
Yes.
up on the enthusiasm. So what David will get from Alyssa is going to be Alyssa's enthusiasm of 30% multiplied by the weight that her words have, the friendship level. That this edge is known as the weight. So think about to get to David from Alyssa, how do you go there? You think of the value, the enthusiasm she has, multiplied by the weight. That will be what David gets from Alyssa. What will David get from Elian?
40% times 20%.
Yes, exactly. So this is the enthusiasm that Elian has is 40%. So David's going to pick up. David is exposed to that level of enthusiasm, but whatever the friendship has, the friendship he's going to weight it by the friendship. So the enthusiasm that Alyssa had, you know, that's what she's exuding in when she's talking to people like Lachlan, Lachlan and David. You know, like that's the enthusiasm that she will exude, and when she's talking to David, for instance, like, you know, based on their friendship, that's what he's going to get out of it. But when David is talking with Elian, he's going to say, okay, I barely know Elian, so it doesn't really have much of an impact. Even if Elian has more enthusiasm than Alyssa does, David's it's not going to make as much impact. This is 0.08 versus 0.15, you know, just because they're slightly closer. And what do you think Sarah will give David? Like, what will David get from Sarah?
90% and 70%.
Multiplied by 0.7. So this is what David is going to get from Sarah, essentially. So David is sitting there at lunch, and he's gotten these three people coming up to talk to him. You know, Alyssa's coming with 30%, but this is what she means to him. So the impact that Alyssa has on David is measured by how much enthusiasm she had multiplied by how close of friends that they were. That's what's going to stay in David's mind about the interaction. Next is the interaction with Alien. Alien did have more enthusiasm by a little bit, but they're not so close as friends. So it had just a little tiny impact. But there was Sarah, who was really enthusiastic at 90%, and they're much closer. So this will be a 0.63 if you multiply them out. So David is sitting there listening to these messages from these three people, and the input that he's getting about the COVID mask is given by this sum here. Has anybody multiplied it out? Anybody multiply it out?
Is it 1.58? Or, yeah.
0.15 plus 0.08.
Like,
Oh, it's 0.15.
like 1.5. Oh, wait. Okay.
Okay, yeah, it's 0.86. Someone got 0.86. Yes, exactly. A very good try though. So 0.86. So 0.86 is what David is going to get as net input, right? From all these people. So you can imagine that certain people need to be given more of a push, right? To be activated. Like, you know how some people need to be coaxed a lot, right? For them to take action. So David might be, maybe David, no offense, David, maybe David is really stubborn. And he needs to be given a huge push to do something. He's a popular kid, his reputation's on the line, right? So the net input he gets from this is 0.86. But David also has a lot going on too, right? So this is sort of the input, you know, like the neurons are firing from their axon terminals to this neuron, for instance. And what the input that David gets is 0.86. But what happens is David ultimately fires out 0.2. There's another function that comes in between. So what happens is this input is then put into another function. It's like f of a function of 0.86. It's some function. Like, you know how yesterday we talked of functions? So this is like f of 0.86, which is equal to 0.2. So this is called an activation function. So what happens is that there's certain input that David receives, like a neuron receives the inputs from all different neurons. And if it gets enough of the signal, like the chemical, like the voltage change inside the neuron, then it fires. If it reaches a threshold of negative 40 millivolts, if it reaches a threshold of negative 55 millivolts inside the neuron, then it fires an action potential. Like that's in biology, you guys will learn, or you guys may learn that in biology that if a neuron hits a certain voltage inside the neuron, it fires an action potential. Similarly, this is the net input that David received, but what happens is that it's put in another function that determines what David will output. So don't worry too much about this. It's just called an activation function. And based on that, David fires at 0.2. So you can imagine that he gets a lot of coaxing from you guys, the three of them, Alyssa, Elian, and Sarah. And at the end, David only gives at 0.2. He could be like a really, really popular student, and he could be given a lot of input from you guys, but he's just going to output this much. Because he's got a lot going on. He's got a reputation, right? You guys may really care about it, but he might have like 10 other things going on because he's super popular. So do you guys understand that? Like there are these things that are called activation functions. So these are things that you have to also set as well. There are these things called activation functions. And in activation functions, they have like value rectified linear unit. They have sigmoid. They have soft max. These are all like formulas: soft plus, soft sine, tan h, cell u. They have like different functions here, but that's a similar idea. So what happens is that David is going to receive the signal and then will send a signal to Brianna. So let's say that the closeness could be like 0.41 between David and Brianna. Then what does Brianna get from David?
The point 0.86 times the 4.41.
0.41, but close. But what will David output? Not 0.86, but like what's the value inside David, a neuron? Well, I guess it's similar to that. It's like 0.41 times f of 0.86. And do you know what f of 0.86 is?
Well, 0.2.
Yes. So that's what Brianna will get from David. So the idea is that I don't want you guys getting too confused on it. This is something that we actually don't, we can set this before. But what happens is that this is the input. This part is always the same. This 0.86 is always the same. Like not always the same, but the idea, the calculation. This is called a weighted average, WEIGHTED average. So you take these values and you multiply the enthusiasm weighted by the edge weight here. And then you add this enthusiasm by this weight, the weight of their friendship, how close they are. And this value multiplied by this weighted. And you add those together. Like that's a weighted average. That you're weighting it by the closeness that these individuals have and their enthusiasm. And that's how you get this 0.86. But what happens is that there are these activation functions, much like in our own neurons. Neurons receive signals from all sorts of other neurons, and they are getting all these ions coming in. But what they do need to reach to trigger is an action potential. Like if you've ever felt like sneezing, or if you've ever felt like crying, if your lower lip is quivering, and then sometimes it goes away, or if you feel like sneezing, you have the action potential and it can get triggered. Or if you've ever felt like like rage or certain emotion like inside, and when I was teaching neuroscience to students, and I'll be putting up on my channel some videos to help you guys as well, there's an idea of neuroplasticity, like our brain and our neurons being very flexible and changing. The idea is that in our brains, the signals that they receive, why certain neurons in our brains fire and send other signals. Like if you go outside, I live in Wisconsin right now. I'm home in New Jersey, but there it's super cold. And if some of you guys who come from Florida or other warmer states go there, within a few seconds you might just be really, really cold. But I might be more used to it because like our neurons that like are dealing with temperature regulation and our reaction to it. Like I'm more desensitized to certain things. So it's the idea of what triggers certain people, like the word trigger. Some people more sensitive than others, how their brains are wired is different. When one neuron fires an action potential might be different from what makes, like for the same reaction, our brains and the neurons that connect them are so unique and based on our genetics, our life experiences, on our development, like how our brains are shaped is different. So that's the same idea here, that even if you receive a certain input from all of them, you have to put them into some activation function, because even if a neuron receives signals from other neurons, it needs to hit a threshold to fire. So that same idea is here, that even if you get some certain input, net input from these other neurons, what you will release could be different. It's a similar idea in a way. So I said that it's based on how the brain works. It's sort of adapted. It's like your brain gets input from other neurons, but sometimes it may not be enough to reach something called the action potential. So even though this is the input, you put this into another function and then it gives you 0.2, and then that's what David will output. It could be 0.86 if you use something called an identity function. If you said, sometimes people can do f of x equals x, and then exactly whatever, this outputs some function. Like in class, you guys might learn like 2x, like f of x equals 2x minus 3 or something, right? You guys might learn a function like this, right? Like functions. Then if you take 0.86 into this, like, what you output could be a function of this, right? Do you guys understand this? Is it confusing? And how do you guys feel about this? Are you guys okay? Okay, guys, so don't stress too much about this, honestly. I just really want you guys just to understand the concept, which is just the same thing, that you don't have to memorize this 0.2. Honestly, if you guys get 0.86, that would be okay. You just need to know that you just plug it into some other function. And I hope I can inspire you that AI scientists do make a lot of money. AI researchers are making more than $1 million, even at like nonprofits. The Times is saying, New York Times, and I don't want to like talk more about this, but demand. There's a mountain of demand and a trickle of supply. There's a lot of demand for people who know AI, and there's very little people who know AI. Not as many people. So this is a huge career that's upcoming. So part of the difficulty in AI is figuring out. Imagine I'm like helping you guys, Alyssa, Elian, and Sarah. I want your guys' idea to work. So and then what happens is David is going to be sending messages to Brianna and Kieran, and maybe it could be different. Alyssa could be maybe closer with Lachlan, or maybe Elian is closer to Lachlan. So whatever Lachlan gets might be different from what David gets. And you see that if the closeness between David and Brianna is something else, like instead of 0.41, if it's like 0.44, then this will be 0.44 times 0.2. Do you guys see that? It's like a domino reaction. So when you get to the output, what Shayna is going to do is this decision is like is a happy decision, where COVID mask, yes, and this one is COVID mask, no. And what Shayna is going to look at is which one is higher, yes for the mask or no for the mask idea. So that's what's interesting about the output layer, is that in the output, the end value is the one that you choose between wearing the mask or not wearing the mask. Did you guys sort of see? Does anybody have questions on this? Anybody want to ask any questions? So this is stuff I learned in grad school. But I just want you to have the idea that neurons are just signaling to each other, sending a message across.
I have a quick question.
Oh, yes.
So if we were to think of this in like programming, it's just basically the random number generator is going to function. It's going to either more functions or random number generators, which eventually leads to an output.
Yeah. What do you mean by random number generator? That's
like you get a random value and it tries to optimize that random value accordingly.
Yeah, I know, but yeah, I know random generators. They try to choose random numbers, but which part do you think is random number generator?
The input.
No, actually the input is and we'll actually talk about this. The input is like an image, or it could be some set of data that you have. And that's and based on this data, you are trying to make a prediction. We'll actually talk about this right now. But what's randomly generated to begin with could be these weights. But so I guess we'll talk more about that, David, but and then I'll come back and answer if I haven't answered that. But the idea is that you have a set of these neurons, and you're trying to go from one neuron to this next neuron and this next layer. But you have to see, this neuron looks at all the things that are coming into which are these 3 neurons. And it's sort of weighting them by, you think of coming to this neuron, how do you get to this neuron? You get to this neuron by this part, by this part, by this part. So you have to take this part multiplied by this weight, plus this part multiplied by this weight, plus this part multiplied by this weight, add them up together.
And that goes to function.
and that goes into some function. That function could very well be an identity function like f of x equals x, and then this would be 0.86. But it doesn't always have to be. You can decide what activation function you have, but don't get too confused on it. Just the only thing you should know is that this net input is put into some function, and you can decide what this function is. And then this output comes here, but the same function that is used here must be used in the whole layer by all these neurons. Maybe popular, and it could be based on your model. Like maybe I think that popular kids really need a lot of pushing because they're so popular. They've got a huge reputation. Even if David is receiving like 0.86 as input, he's only going to give out like 0.2 because he's got so many things and he's got a reputation. Or maybe I think that popular kids are super friendly. So even if he gets 0.86, he might even give out 0.9. It could go the other way. Right, but this is me to figure out like which function I want to use. It's like a game plan, right? You know, like these football games or shows, they show like how people come up with like, you know, on a whiteboard, how they come up with plans of how they think people will act on the field.
Okay, so let me try to rephrase this. So input is basically data, the data that you want or something, and then the rates can be random, and the function goes with the layer.
Yeah,
Basically.
the function goes with the layer, or it can be across a neural network. The function is something you determine.
So the rates are random between each neuron in the layer, right?
Yes. So what you're going to notice is that you set up this architecture to begin with. You set this whole thing up like beforehand, and you can keep playing around with it. So you set up, okay, I want to have these many neurons in each hidden layer, and I want these many hidden layers. So you set this up to begin with. And which one you use can make a huge difference. That's why AI researchers are paid a ton of money, because sometimes it might be difficult to determine what structure do I want to use, how many hidden layers, how many of these neurons in which hidden layer do I want. That's the idea. And then which functions do I want to use? Now and you have this input, this is your data. A part of training the neural network, what that involves is when you're training the neural network, you're actually figuring out what these weights are along the way. That's what the training step does, is it actually figures out the optimal weights to give between these neurons so that for whatever data you give, it can predict the right output. That's actually what the training does. It takes your data, it takes this architecture that you've determined how many layers you want, how many neurons in each layer. You could have multiple, you can have like 10 hidden layers, or you could have like 5 hidden layers. You could have 20 neurons in a layer, you could have 10, you could have 2, whatever you want. But based on that, you fit a model for the data, and training tries to find the weights that best give you the output. Because in the end, whether the weight from David to Brianna is 0.41 or 0.44, it all changes the math. Like if the weight that Alyssa had, the friendship between Alyssa and David, if that instead is 0.51, for instance, then this would be 0.3 times 0.51, and then this value would not be 0.86. This value would be something else. And then when you update this value, then this thing could be updated. Do you guys see that? So and then this value gets updated, and then instead of 0.2 being this, maybe it could be 0.24 or something. And then this value is then being multiplied by this value to then be, instead of 0.44 times 0.2, it could be 0.44 times 0.24. Do you see that? Like this value multiplied by this value. So I'll give you guys a break soon. Just bear with me, guys. Sorry for that. Does anybody have any additional questions before I head on to the next part?
Oh, I think you already answered this, but is the function determined by the programmer or
Yes.
like, okay.
But that's sort of why you see, like there's all these different functions. So is it okay if I clear the slide, guys? Okay, so there are these different functions here that you can decide. These are activation functions, and they are mathematical functions that you can use. So that's why AI scientists are paid a lot of money, because you have to determine which function do I use. what is this layout of the neural network. So it needs some math knowledge, some trial and error as well. So what function do I use? Tan H takes this input, like, and it puts it to a function. Like, let me show you. Sigmoid is a very well-known one. So if you guys have heard of Euler's number, this is like 2.7. So 1 plus 2.7 to this exponent. This is a formula. You put in your input and then you get some value in the end. Do you see that, guys? These are some functions that you take. So if you have 1 here, you put in 1 over 1 plus e to the negative 1. And you can even put this in your graphing calculators if you guys do that. Or just you can even find this value out. Or they have this hyperbolic tangent as well that's using some tan thing. I don't want to scare you guys too much, but they're just like they're just different activation functions. So based on this idea, I want to add in another part here from our input. So do you guys remember what slope-intercept form is? Does anybody know what slope-intercept form is? Y equals?
mx plus b.
Yeah, thank you guys. Mx plus b. And do you know what this b is?
The y-intercept.
Mm-hmm. So similarly, we can also add in a bias. You know, that's what it also can be called a bias term. And these are things in front of your x. So if we pretend like this 0.2, which is David, is this neuron here, then based on the formula, what is this input to this neuron? I know some part of it could be written there, but what is the input to the neuron? Like, what does David get based on the formula like we talked about? So these are the input values. Remember, like 0.2, 0.3, 0.4, 9. So what would David be getting as input from this? And some of the formula could be written there, but I just want you guys to say it. Like, what would David get? Using the same idea we just talked about the weighted average.
I think it would be x1 times w1 plus x2 times w2 plus x3 times w3.
Plus x3 times w3. And you're missing one more thing we just added right now.
Oh, 1 times 1b.
Yeah, plus 1 times b, which is just the same thing as b. So it's just the same idea. That's the input that David is getting. David is getting the enthusiasm levels from each of you guys multiplied by the weight of friendship. And this part here, this is the W3. Sorry, I forgot to add that. But that's sort of what input David is getting. Okay, that's the input David gets from each of you guys, plus some bias, just some y-intercept term that you may or may not include, but that's the input. So this is the input. And then the output is basically going to take this input and put it into a function, an activation function. So it's just the idea that neurons themselves receive so many signals from other neurons. Then they take those signals and then they decide to spread the signal to the other neurons based on that. So like sigmoid, what we talked about as well, you can take some net input and then figure out what is the output. Like if David had a 0.2 that he output, but he got 0.86 in net input. So these are just functions that people do. So neural networks are just mathematical functions. It's just a long thread. It's almost like a domino effect. That's how I would describe it, that whatever this neuron is firing out, if this thing changes to being like a 0.6, then what this person gets from this neuron will be like equal to 0.2 times 0.6 plus whatever this neuron is getting from other neurons. So there's that layer of, or if it changed from 0.6 to maybe 0.4, it would be 0.2 times 0.4, right? So whatever this David is outputting, it's based on whatever David received from all three of these people. You change any of these weights, this value will change. If this value will change, then this value will change too. You see that? Because it's based on this value. So if you guys are sucky with math or you make a lot of typos and mistakes, back in the day, it would have really sucked to do this by hand. You make one mistake here and like everything else is like sort of like, if you make one mistake even here, this is impacted, this being impacted like affects all of this stuff down here. You make one small mistake. Did you guys see how it's all connected? You can all just trace it from here to here, like this impacts this, this, and then this impacts this and this. So are you guys confused on anything so far? I just want to quickly show you guys the concepts. I know it's like a lot to take in. You guys want to take like a quick like 3-minute break right now? So you can come back at like 36 then, please.
Miss Kohler?
Oh, yeah. Hi, Alyssa. Yes?
I have to go. So I just want to say
Oh,
thank you for a session today.
okay. Okay. Yeah. Yeah. I mean, I guess, okay. Yeah. I know if you guys have to go, that's okay. Yeah, I could try to send the notes if you guys have missed anything then, you know, if you guys have to go.
Yeah. Thank you.
Hey,
Bye. See
thank
you
you. Bye, Alyssa.
tomorrow.
I'll see you tomorrow as well. Okay, guys. So I just, if you guys are back from the break, so we can use neural networks to do computations, for instance. So at the end of the day, a neural network just does a lot of computations for us. So what I want you guys to see is that, like, for instance, you know, if we fill this out, like this is 0.2 for David, this could be 0.5 for Lachlan, 0.5, 0.9, 0.1. These are a set of different values. And then this output layer has a set of values. You know, it's like the principal deciding, do I let the students go with the colorful mask idea or do I not? So that's the same idea. So we can use neural networks for computations. So biological neural networks are many orders more complex than the best artificial networks. So we can use neural networks to represent complex nonlinear functions. So an idea is in the COVID mask problem, we can output a set of probabilities, you know, that somebody has a mask on or has no mask. And we choose the one, so these two actually have to sum up to 1 in the output layer in a lot of applications. So we choose the one that's actually highest. So if this is 0.9, that means 90% chance the model predicts that this person, this little guy here is wearing a mask. So we're going to go with the majority. So do you think that this is a good model? Yeah, does it make a good prediction? See Sarah nodding. Yep, I think this is a good model because this guy is wearing a mask. So it made a correct prediction. So it all comes down to what this value is. This value comes from what these other values are here. It comes from here. It comes from here. It comes from here, here, here. It comes from all these values here. And we choose the largest value. That's what we go with. So similarly, in this example, this is Obama is 0.1 and no, 0.9 and not Obama is 0.1. So do you guys also think this is a good model? Yeah, it's a good model because it's pretty correct. This is Obama. This is a pretty spot on model. They did a good job here. So you guys might wonder, how do we get these calculations, right? So an image is just a set of pixels, and pixels have values. So if you look at this image of an S, for example, so we take an image of Obama and then we can predict if it's Obama or not. And this is a very toy example. In reality, what happens is that we have an image and over here, and it's a set of values. So each value in the pixel corresponds to a value between 0 and 250. So this corresponds to this value here. This value here corresponds to like 250 here. So do you guys notice anything about these numbers? Yes. We turn it into a matrix. 250 is white and 0 is black. So, okay, so what they then do is they sort of do something where they take this, where they take each of these rows here, like if you can imagine this over here, and they stack it into neurons. Each row gets stacked like this. Let me also show you another example here with this. And then this gets stacked here, for instance. And these are all neurons, you know, they get stacked like this. You can imagine, right? Like we had 3 neurons in the input. So this idea is really similar. Like each row gets stacked into a set of inputs. And we normalize these values so that they're between 0 and 1. So we probably divide it by 250 or 251. I think 251 is a max. We divide all these numbers by 251. So here you see a bunch of zeros in front. And this is 89, this is 5, this is 39. They just put zeros in front just so that it all lines up for you guys. It's super neat. That's what they put zeros in front, you know, so it just is all lined up. This is a 9, that's a 9, 6. So this is the idea. You take an image, you can turn it into black and white, get this set of values for the image into a matrix. You know, so each and every pixel is a value that you can map. And then you can just see these set of input values over here. Does this make sense to you guys? And you can normalize it. That means to make them between 0 and 1. And this is what the input looks like. Any questions on this?